Okay, ready to dive into some seriously cool AI research.
I'm ready. Let's go.
You sent us this paper about something called stick-breaking attention.
Uh-huh.
And the name alone had me intrigued, I have to admit.
Yeah, it's a catchy name.
So we've got the academic paper right here.
Right.
We found some code on GitHub,
Nice.
even some interesting online chatter about it.
Cool.
So what's the mission?
Well,
We're going to figure out if this is just a fancy theory
okay.
or if it could actually revolutionize
Yeah.
how AI understands the world.
Sounds good. And of course, I think what's really exciting about this is it tackles a problem that's kind of been plaguing AI for a while. This whole information overload thing. You know, think about it. Humans are constantly bombarded with information.
Yeah.
But we're pretty good at focusing on what's important.
Right.
Especially the real recent stuff.
Yeah.
Traditional AI models, not so much.
It's true. It's like trying to read a news article where the big reveal is in the last paragraph, but you get stuck on a clickbait headline from the beginning.
Exactly. You lose the flow, you miss the point.
And that's kind of what's been happening with some AI,
Right.
especially these transformer architectures. They rely on this thing called softmax to figure out what to pay attention to.
Yeah.
And while it works, it's got its limits.
Exactly. Softmax can be, well, a bit of a scatterbrain.
Okay.
Its attention is scattered all over the place. It can have trouble understanding that the order of information actually matters. Like the latest update is usually the most important.
Makes sense.
So this is where stick-breaking attention comes in.
Okay.
Imagine you have a stick and you're breaking off pieces to give to different people. The size of each piece represents how much attention the AI model is giving to a specific part of the information.
Okay.
With stick-breaking, the most relevant information gets the biggest pieces.
I love that it's like the model is learning to prioritize.
Exactly.
Okay, this latest development is crucial. Got to focus on that.
Yeah.
It makes me think about how I try to manage my to-do list. Important, urgent things go to the top.
Absolutely.
But it's not just a cool idea.
Right.
They actually built this thing.
You're absolutely right. They took this concept and made it a reality.
Wow.
They even managed to get it working at a large scale.
That's impressive.
Which is no small feat.
Not at all.
They use this platform called Triton. It's like giving your AI a super-powered engine.
Yeah.
But like any powerful engine, it needs the right fuel and tuning.
Right.
They had to get creative with memory management.
I see.
Because the way stick breaking works is computationally a bit more demanding than the traditional methods.
So it's like they had to break a few sticks to get this to work?
You could say that.
Okay.
But the fact that they got it to work at all on a large scale, that's pretty impressive.
All right, now for the part I've been waiting for.
Okay.
The experiments.
Let's do it.
They put this stick breaking to the test on all kinds of tasks, like language modeling and question answering.
Right.
But the real nail biter for me were these length generalization tests.
Okay.
They trained the model on a fixed amount of text and then threw longer, more complex sequences at it.
Interesting.
This is key because, let's face it, the real world is full of long, messy information.
These length generalization tests are crucial. Yeah, it's like training a chef to make a simple omelet and then asking them to whip up a 5-course meal.
Right.
Can they adapt their skills to handle something way bigger and more intricate?
And drumroll, please, did stick breaking rise to the challenge?
Oh, it did. It totally did. Stick breaking consistently outperformed those traditional methods.
Nice.
Even when the information got really long and complex. It's like it had this superpower, you know, this amazing ability to keep track of the important points, even when there are all these distractions thrown in.
That's what blew my mind, too. It's like finally an AI that can handle those needle in a haystack situations.
Yeah.
You know, like when you're searching for that one crucial fact in a massive research paper. Speaking of which, they use this benchmark called Ruler to test exactly that.
Yeah, the Ruler benchmark is designed to be tough. It's all about finding specific information buried within a ton of text.
Okay.
And stick breaking aced it.
Really?
Especially those tasks where you need to like follow a thread of information over a long stretch of text.
So it's like having a detective with an incredible memory for details.
Exactly.
So this is all super impressive, you know, from a research standpoint.
Yeah.
But you know me, I always want to bring it back to the real world.
Of course.
What does this mean for you, the listener?
Right.
How could this impact your daily life?
That's the question, isn't it? I think the potential applications are huge.
Yeah.
Imagine summarizing lengthy reports in a snap.
Okay.
Or having a virtual assistant that can actually understand a long email chain.
Right.
and draft a perfect response.
Hmm.
Stick breaking could be a game changer for all sorts of tasks that involve processing tons of information.
Okay, so picture this. You're scrolling through your news feed,
Oh.
and instead of getting overwhelmed by a million headlines,
Yeah.
your AI assistant, powered by stick breaking,
Right.
summarizes the key points of each article,
Nice.
highlighting the most recent relevant updates.
Exactly. It's like having a personalized news digest.
That's awesome.
Cuts through the noise and gives you exactly what you need.
And think about research. Instead of spending hours sifting through endless academic papers,
Yeah.
your AI research assistant could quickly scan through them, pinpoint the key findings,
Right.
and even connect them to other relevant research.
It's like having a super-powered research librarian at your fingertips.
This is all starting to sound like science fiction.
I know, it's exciting.
But here's the thing.
Yeah.
We also need to be realistic.
Sure.
Are there any downsides
Mm-hmm.
to this laser focus on recency?
Mm-hmm.
Could there be times when looking back at the bigger picture, even if it's older information, is crucial?
That's a really insightful point. And yes, there are potential downsides to consider. Just like having a super detailed memory can sometimes make it harder to see the forest for the trees.
Right.
An AI that's hyper-focused on recency
Yeah.
might miss out on crucial historical context or broader trends.
So it's like if you're analyzing historical documents, maybe you do need to consider those events from way back when.
Exactly.
Even if there's been a ton of news since then.
Right. The key takeaway here is that stick-breaking attention is a powerful tool.
Okay.
But like any tool, it needs to be used strategically.
It's not a one-size-fits-all solution.
Right. And there will be situations where other approaches might be more suitable.
That's a great point. It's all about understanding the strengths and limitations of different AI techniques.
Absolutely.
And choosing the right one for the job.
It's like having a toolbox full of different gadgets.
Right.
You wouldn't use a hammer to tighten a screw, right?
Now for our listeners who are itching to know a little bit more about how this magic actually works.
Okay.
Let's get a little technical for a moment. We don't want to get bogged down in the weeds.
Right.
But I think it's helpful to understand the basics of how they built this thing.
Absolutely. I think a little peek under the hood can give us a greater appreciation for how ingenious this research really is.
Okay.
So remember we mentioned earlier that stick breaking requires a different way of calculating things compared to the traditional methods.
Right.
Well, this has some implications for how the model is trained.
Okay.
And how efficiently it uses computing resources.
And they had to use that platform called Triton, which is like a souped-up engine for AI, to make it work at a large scale.
Right.
But even with that, there were some challenges, right? Like,
yes.
How do you make sure the calculations are happening in a right order when you're dealing with massive amounts of data? It's not just about crunching numbers. It's about crunching them in the right sequence.
They had to come up with some really clever techniques to make this work.
I see.
One of the key things they did was to optimize what's called the backward pass.
Okay.
During training.
Backward pass.
Yeah, this is a bit like fine-tuning the engine.
Okay.
To make sure it runs smoothly and efficiently.
Okay, I'm going to need you to break that down for me a little bit more.
Sure.
Backward pass. That sounds super technical.
You're right. It does sound a bit jargony.
Yeah.
But imagine you're teaching an AI to recognize different types of flowers.
Okay.
You show it a picture of a rose.
Uh-huh.
It makes a guess.
Okay.
And then you tell it if it was right or wrong.
Got it.
Based on your feedback, it adjusts its internal parameters
to
get better at recognizing roses. That process of adjusting the parameters is called backpropagation.
Okay.
And it involves calculating these things called gradients.
So gradients are like instructions for the AI on how to improve?
Exactly. And this backward pass is a way of calculating those gradients in a more efficient way.
Got it.
They basically split the process into two phases, which helps save memory and makes the calculations faster. It's kind of like optimizing a recipe to use fewer pots and pans
I like that.
without sacrificing the flavor.
Yeah.
You get the same delicious result, but with less cleanup.
Okay, that's a much better way to explain it.
Good.
Now, even with all those optimizations, stick breaking is still a bit slower than the traditional methods, right?
That's true. It's a trade-off.
Okay.
You gain the benefits of improved positional awareness and the ability to handle longer sequences.
Yeah.
But it comes at the cost of a bit more computational power.
I see.
It's like choosing between a sports car and a luxury sedan.
Okay.
The sports car is faster off the line, but the luxury sedan offers a smoother ride.
I love that analogy.
Good.
It's all about choosing the right tool for the job.
Exactly.
But here's what impressed me most about this research.
Okay, what's that?
They didn't just stop at the theory. They really put in the work to make this practical.
Right.
They tackled the computational challenges head on. And they even came up with some clever tricks to make it even more efficient.
Uh-huh.
Like that thing called block skipping.
Ah, yes, block skipping.
Yeah.
This is where we really see the elegance of stick-breaking attention.
Okay.
Remember how it prioritizes the most recent relevant information?
Yeah.
Well, once it's found that key information, it doesn't need to keep looking back at the older, less relevant stuff.
Okay.
Block skipping lets the model skip over those irrelevant parts.
Right.
Saves valuable time and resources.
So it's like reading a mystery novel
Mm-hmm.
and figuring out who the killer is halfway through.
Right.
You don't need to read every single detail from that point on. You can just jump ahead to the resolution.
It's a brilliant way to streamline the process
Cool.
and make stick-breaking attention even more powerful.
Okay, so we've delved into the technical details a little bit.
Yeah.
But let's zoom out for a moment
Okay.
and consider the bigger picture.
The big picture.
What are the implications of stick-breaking attention? Could this fundamentally change how we build AI models?
That's the million-dollar question.
Yeah.
And while it's still early days,
Uh-huh.
I believe the potential is enormous.
Okay.
Stick breaking addresses some of the core limitations of traditional AI models,
Yeah.
particularly those struggles with positional awareness and information overload. It's like we've given them a new superpower,
Right.
the ability to focus and prioritize just like we do.
So this could be much bigger than just a new algorithm.
Yeah,
It could change the entire landscape of AI.
I think it has that potential.
Yeah.
If stick breaking proves to be as effective as it seems, it could lead to a paradigm shift
Okay.
in how we approach natural language processing
Yeah.
and other areas of AI.
Let's paint a picture for our listeners.
Okay.
What could this mean for the future of AI?
Right.
Could we see AI that can truly understand complex narratives, reason about the world like humans do,
Yeah.
or even write compelling novels and screenplays?
Those are all possibilities.
Wow.
It's impossible to predict the future with certainty.
Right.
But stick-breaking attention is a significant step in the right direction.
I, for one, am incredibly excited to see where this technology leads.
Me too.
But before we get too carried away,
Yeah.
I think it's important to acknowledge that stick-breaking attention is not a magic bullet.
Right. No technology is perfect,
Yeah.
and it's crucial to understand its limitations.
Absolutely.
Yeah.
We did touch upon the fact that its laser focus on recency could potentially be a weakness in certain situations, right?
Exactly.
Like, what if understanding the full historical context is really important for a particular task?
Imagine you're building an AI system to analyze historical documents.
Okay.
In that case, understanding the broader context,
Yes.
even if it comes from older information,
Right.
is absolutely crucial. Stick-breaking attention's bias toward recency
Right.
might actually be detrimental in those scenarios.
So it's all about choosing the right tool for the job.
Exactly. You wouldn't use a scalpel to build a house,
Right.
and you wouldn't use a hammer to perform surgery.
Each tool has its purpose,
Right.
and it's about understanding when to use which.
Precisely, stick-breaking attention is a powerful tool.
Yeah.
But like any tool, it needs to be used thoughtfully and strategically.
I think that's a great point to emphasize now for our listeners who are ready for even more insights.
Okay.
We're going to dive into some specific experiments that the researchers ran
Right.
to put stick-breaking attention through its paces.
Good.
We'll uncover how it performed in different scenarios
Okay.
and what those results tell us about its potential.
Sounds good.
Stay tuned for the final part of our deep dive into this groundbreaking research. All right, we're back and ready to dig into some fascinating experiments that really showcase what stick-breaking attention can do.
Sounds good.
One that caught my eye was this thing called multi-query repeated associative recall, or MQRAR for short.
MQRAR.
Yeah, I know that sounds like a mouthful, but trust me, the concept is pretty straightforward.
It is.
It's like trying to remember where you last put your keys, even though you've moved them a bunch of times throughout the day.
Wait, where did I put that thing? Moment we all have.
Exactly. So how did they test this with stick breaking?
Okay, so they basically set up a scenario where the AI model is given a series of assignments.
Okay.
Like A equals 5, then maybe later on A equals 2.
Right.
And the model has to keep track of these changing values
Hmm.
and be able to recall the most recent one when asked.
Gotcha. So it has to remember the A is now 2.
Right. And stick-breaking attention really shines here because it's designed to prioritize that latest update, even if it's buried under a pile of previous information.
So it's like having a mental sticky note that always reminds you of the most recent update, even if you've been bombarded with other details.
Exactly.
Did stick breaking outperform the other methods in this memory game?
It crushed it, especially as the number of these key value pairs increased. It was remarkable to see how stick-breaking attention maintained its accuracy,
Yeah.
even when the sequence got really long and complex.
So it never lost track.
The other methods relying on that traditional softmax approach just couldn't keep up.
Wow. Okay, so that's really impressive.
Yeah.
Now, another experiment I found super interesting was their work on length generalization. That idea of training a model on a certain amount of text and then seeing if it can handle something much longer.
Length generalization. Yeah. It's a crucial test because in the real world, information rarely comes in neat, predictable packages.
Right. It's messy.
Think about it. You might train an AI on news articles of a certain length,
Yeah.
but then it encounters a super long investigative report or a dense academic paper.
Okay.
Can it adapt its knowledge to process these much longer pieces of information?
It's like training a chef to bake a batch of cookies and then asking them to create a multi-tiered wedding cake.
Perfect analogy.
Can they scale up their skills and apply their knowledge to something much more complex?
And with stick-breaking attention, it seems like the answer is a resounding yes.
They were able to do it.
They trained a model on sequences of a specific length and then tested it on sequences that were twice, 4 times, even 8 times as long.
Wow.
Stick-breaking attention showed this incredible ability to extrapolate its knowledge
Yeah.
and maintain its accuracy even when faced with much longer input.
So this AI is like a language whiz that can just keep reading and understanding no matter how long the text gets.
That's a great way to put it.
What are the implications of this kind of length generalization?
Well, imagine AI that can summarize entire books, analyze complex legal documents, or even understand the nuances of lengthy historical texts.
So it could really change how we interact with information.
Absolutely. Stick-breaking attention could unlock a whole new level of AI comprehension and reasoning ability.
It's like we're opening up a whole new chapter in the story of artificial intelligence.
I like that.
But before we get too carried away,
Yeah.
I'm curious, were there any scenarios where stick-breaking attention didn't perform as well?
That's a great question. And it's important to acknowledge that while stick-breaking attention excelled in those tasks requiring a focus on recency, there were some hints that it might not be ideal for every situation. For example, in certain retrieval tasks, where understanding the full historical context is super important.
Right.
Stick-breaking attention's bias toward recency might not be the best fit.
It might actually be a hindrance.
It's like using a scalpel when you really need a hammer.
Yeah, you need the right tool for the job.
The right tool for the job depends on the specific task at hand.
So it's not about replacing all existing AI techniques with stick-breaking attention, but rather about adding it to our toolbox and knowing when to utilize its unique strengths.
Exactly. It's about having the right tool for the job.
Yeah.
Just like a skilled craft person wouldn't use a screwdriver to hammer in a nail.
Well, this has been a fascinating deep dive into stick-breaking attention.
It has.
We've covered a lot of ground from the core concepts and how it works to its potential applications and limitations.
It's been a pleasure exploring this groundbreaking research with you.
Same here. I'm excited to see where this technology leads and what amazing applications emerge in the future.
Me too.
And for our listeners, we hope you've enjoyed this journey into the cutting edge of AI research.
Yes. Thank you for listening.
Until next time, keep those minds curious and stay tuned for more deep dives into the world of technology.